Okay, so today we're gonna work on this worksheet number 10 about calculus of parametric curves and the complex numbers. We have 7 questions here. That's a lot to do, and let's go over them one by one. For question 1, find an equation of the tangent line to the curve this at the point -1, 2. Okay, so we actually have known how to do this in the course math 1500, and in here we just gonna do this the other way in the form of parametric curves. So that is same stuff. We need to find the tangent line, so we need this point slope form of the line, right? The slope is k and the point is x0, y0. So we've known that the point x0, y0, it's already given, which is this -1, 2, right? So we can just use it. And for the slope, it's defined by dy over dx. But in this case, we're gonna use the parametric form. So instead of using dy over dx, we're gonna use dy divided by dt over dx divided by dt. That means we're gonna find this dy over dt and dx over dt respectively. So now let's work on them. Dy over dt here is equal to d of this over dt, which is 3t squared, and dx over dt, x is this one, right? So we have cos pi t times pi, that's dx over dt, very simple. And now we take the division of them, so k is equal to 3t squared over pi cos pi t. So you can see that the slope can change according to the value of t. So for any given t, the slope could be different. So we need to figure out what that slope is exactly at the point -1, 2, which means we need to find out the value of t. The value of t corresponds to this point x equal to -1 and 2. So we're gonna write this xy equal to -1, 2, right? And then this is converted to x. This is x equal to -1, and y equal to 2. And from here we can solve that t is equal to -1, which means the value t equal to -1 corresponds to the point -1, 2. So to find the slope at this point, we just need to plug in t equal to -1 to this expression to find this k here. And finally, we found that k is equal to -3 over pi, right? And we just plug in x0, y0 back into the equation, and this k back into the equation, and we obtain that the equation of the line is y minus 2, 3 over pi negative x plus 1. And that is very simple, question 1. It's nothing more complicated than dealing with just the derivative of the parametric equation. So now let's move on to question 2. Consider the curve x equal to this, y equal to that, right? The first question, find all points on the curve where the tangent line is horizontal and where the tangent line is vertical. Okay, so firstly we have to understand what it means by tangent line to be horizontal. Okay, horizontal means that dy over dt is equal to 0 and dx over dt is not equal to 0. And more formally speaking, it's gonna be like a limit t goes to t0, dy over dt of t, this function is equal to 0. This derivative equal to 0. That means horizontal line. And the vertical tangent line means it has the infinite slope or the slope does not exist. In terms of this, we have dy over dt equal to not equal to 0, but dx over dt equal to 0, or this. So now to find out those points, for the horizontal case, we're gonna let 2t equal to 0, and then this is not gonna be 0, okay? And then this implies that t equals 0, and then we plug in t equals 0 back into the expression x equal to this and y equal to that, and we found that x is equal to 0 and y is equal to -1. So that is this point, 0, -1, which means at this point the tangent line is going to be horizontal, okay? And for the vertical tangent line, it's the other way around. We must have 2t not equal to 0, and this is 0, which implies that if we solve that, t is equal to positive -1, and it implies that x is equal to positive -4 and y is equal to 0, right? And so we have 2 points, right? 4, 0 and -4, 0. And so at these 2 points, we're going to have vertical tangent lines. Okay, so that is this question A, how to find all points where the tangent line is horizontal or vertical. And now take a look at the second question, question B. Determine where the curve is concave up and concave down, where it is concave according to the value of t. Okay, so we know very well from the math 1500 that we need to determine the sign of the second derivative to figure out where is concave up and where is concave down. So we're gonna take a look at the second derivative here. Okay, second derivative. First, we will write out the first derivative that is already done in the first question. That is t divided by 3 times 1 minus t squared. And then we take the second derivative, right, with respect to x, but we write that in the form of t. So it's dy over dt, right, of this one, divided by dx over dt. And so we have the derivative of this one, that is the derivative of the second derivative with respect to t. And in the bottom, we have dx divided by dt, which is this one. And it finally simplifies to this fraction. So our job here is to figure out the sign of the derivative, the second derivative, according to the value of t. So we're going to make this number line here and locate this point, -1 and 1, right? Because we have this factor t minus 1 and t plus 1. And we notice that this yellow circle here, 1 plus t squared, is always greater than 0. So it's not affecting the sign. So the sign will completely determined by these two factors. Right? So we can see that when t is less than -1, both this factor and this factor are going to be negative. So we have negative, negative, and negative. 3 negative signs together, which gives us the negative sign overall. And the function is going to be concave down, therefore. And now we look at the interval from -1 to 1, right? In this interval, it's going to be this t minus 1 still negative, but this t plus 1 is positive. So we have positive, negative, positive, and overall that is positive. Okay, so the curve concave up. And in a similar manner, in this interval, you're going to have negative sign. So it's concave down. Okay, concave down. So the curve is concave down when t is in this interval from negative infinity to negative 1, and this interval from 1 to positive infinity. And we should pay attention to the thing here, that is t belongs to these intervals, right? Not x, right? Because we were dealing with this according to t, not x. So we should pay attention to the variable here is t belongs this interval, not x belongs this interval. And the function is concave up when t is in this from negative 1 to 1. So that is our question B. I think very straightforward. Somebody asked, is next week our last tutorial? I need to check the schedule and to confirm that. And now let's move on to the third question. Find the total area between the curve and the x-axis. Okay, so that is nothing more than doing the definite integral, right? So to figure out the area, we know we need to take the definite integral from a to b and the absolute value of this function dx, right? The reason why we need to take the absolute value is because we are looking for the total area, not the net area, and we need to flip those part of the function that is below the x-axis to above the x-axis. That's why we need this absolute value of f of x. And since this is given in the parametric form, so we need to convert this integration into the parametric form as well. So this f of x is converted into y, okay? And now we change this dx into dx over dt times dt. And we also change the bounds correspondingly. So a is converted to 1, right? B is converted to 3. That was because the t was given in this range. And now we plug in this y into here. So we have absolute value of this 1 minus t divided by t squared, and dx over dt, that is derivative of this guy, which is 2t. 2t is here. And we kind of simplify this a bit and then take this 2 out. So 2 is here, right? And then we find this integral, right? That should be very simple. And finally, the answer is 4 minus 2 times ln of 3. That's the area of this between this curve and the x-axis. Also very straightforward. And so I think now we can move on to the next question. Question 4. Find the length of the curve x equal to ln minus 1 and y equal to secant inverse t, where t is from 1 to 2. Okay, so we've done such a question in the I think the last 2 tutorials, right? I don't remember exactly when it was, but we've done something like that. At that time, we were using the formula definite integral from a to b, and the square root of 1 plus this dy over dx squared dx, or dx over dy dy, right? According to the situation, according to whether it's more convenient to express y in terms of x or x in terms of y, right? But in this case, we won't use these two forms. Instead, we're going to use the parametric form because it's more convenient to express both x and y with t. So it's the same idea, but we kind of replace this form with dy over dt squared plus dx over dt squared, and the integral is with respect to t, so it's dt here. And of course we didn't change the bounds, lower bound and upper bound, right? According to t was given in this range, so it's gonna be from 1 to 2. Okay, and then we just substitute everything in here, right? The derivative of x of this one is 1 over t, and take the square, and This one, that is complicated, but we've done that in the first tutorial, I think. And then just take the square of this one, that is t times square root of t squared minus 1. Okay, and then you square both, okay, and kind of combine the fraction. So we need to find the common denominator. So I multiply this t minus 1 on the top and in the bottom to this function, to this fraction. So they have the same common denominator. And now we can combine the top. See that the top here is t squared minus 1, and this is 1. So this negative 1 cancel with this positive 1. So that on the top we are left with t squared. And this t squared is going to cancel with the t squared inside the in the denominator. Okay, so finally we're going to have 1 over square root of t squared minus 1. And this is some kind of difficult integrals, and we've done something in the last two tutorials about the substitution of trig functions, right? To get rid of such a square root, we need to make something square, make up something square, right? So I'm gonna let this theta, this t, equal to secant theta, which is because we have secant square theta equal to 1 plus tangent square theta. So when this thing square minus 1, we will have tangent square theta. And this square is going to be cancelled with the square root here, right? And I also need to restrict theta in this range so that when I take the square root, I only end up with positive thing instead of plus and minus stuff. That's just for convenience. And now we plug in, okay? This guy here, square root of this expression, is going to be replaced with tangent theta. Okay, tangent theta is here. And then also need to find this dt. Okay, dt is the derivative of secant theta. So that is a secant theta tangent theta d theta, right, in our formula sheet. So I put this here, and we now have this tangent theta cancel with this tangent theta. And we also need to figure out the bounds, the new bounds. Okay, so when t is equal to 1, we have this secant theta equal to 1, which means 1 over cos theta is equal to 1, right? So cos theta equal to 1. Cos theta equal to 1, what does that mean? That means theta is equal to 0, okay? Theta equal to 0. So it's here, new bounds, okay? And the other one, that is when t is equal to 2. When t is equal to 2, that means this cos theta is equal to 1 over 2, okay? Cos theta equal to 1 over 2 means theta is pi over 3. So now we obtain our new upper bound here, right, pi over 3. So the rest of them is just to find this definite integral, and that is known from the formula ln secant square theta, secant theta plus tangent theta absolute value, right, with this upper bound, lower bound, and then we substitute to obtain the final answer, ln of 2 plus root of 3, which is a little bit complicated in a sense of computation, but the idea should be very transparent. Okay, that is our question 4. And now moving on to question 5. Find the area of the surface obtained by rotating the curve about the y-axis. We also mentioned in our last two tutorials that when you rotate a curve about the y-axis, your radius should be x, right? And your circumference should be 2 pi x. So this part is fixed, it has to be 2 pi x. But for the other part here, this part could be up to you, right? Previously, what we did was, like we use 1 plus this dy over dx squared dx, or 1 plus dx over dy squared dy, depending on situation. But in this case, since it's more convenient to express both x and y in terms of t, So we're gonna use this form just like in the fourth question. Okay, so this is dx over dt, dy over dt, dt, and the bounds here is of course corresponding to the bounds here. And now we plug in everything. This x is equal to et sine t. Et sine t is here. And then dx dt, we're going to use the product rule, right? So it's et cos t plus et sine t. That's product rule, and then square. And also product rule for this guy. Okay, that is here. That is a huge expression. But don't worry, we will factor out this et from the bracket, right? Because it has a square here, so when it's factored out, it becomes e to t. And this et as well, okay? E to t here. And we're gonna extract this e to t, both these e to t's, from the square root so that it comes outside, okay? It comes outside and it becomes this e, just et, okay? And our stuff inside the underneath the square root is this square plus that square, okay? And then we're gonna open the bracket, right? When you open the bracket, you can anticipate that you will have cos square t sine square t here, and also cos square t sine square t here. And the middle term in this term is gonna be 2 times cos t sine t, but in that term it's gonna be negative of 2 sine t cos t. So the middle term, they kind of cancel, right? So middle term get canceled, and we are only left with twice of sine square and twice of cos square. And because cos square plus sine square is equal to 1, so this thing turns into just 2, right? Underneath the square root. And now I can combine this e to t, multiply them together, and becomes this e to t, right? And the rest of them is just to figure out the definite integral of this expression, right? And here is a product of the exponential function and the trig function. We've done something like this in the last 2 tutorials, I think, and then we used the technique we used was integration by parts. So we need to let this e to t go into the differential sign so that it becomes this d of e to t. Okay, and we're gonna switch the position of the function, right? And by integration by parts, that is not hard, and we will figure out the integral. That is 2 square root of 2 pi times this over 5. Okay, so that is also not super complicated except for some of the computation here. That is our question 5. Okay, and I think we can move on to question 6. Plug the following points with given polar coordinates and then find their Cartesian coordinates, right? So given the polar coordinate, to find the Cartesian coordinates, we need to understand what it means in the polar coordinate. The first coordinate in the polar coordinate means the distance between that point, from that point to the origin, right? So when this is 3, you have radius equal to 3. That is the radius of the circle whose center is in the origin, right? And then when you have radius equal to 3, you're going to use the formula x equal to radius times cos theta to figure out the x coordinate. Cos theta here, theta is the second coordinate of the polar coordinate, that is cos of 3 pi, which is -1. So now we have this x equal to -3, and y here, y is radius times the sine theta, which is sine 3 pi, that is 0, so y coordinate is 0. Okay, so now this is converted to -3, 0, right? Which is in our Cartesian form. And now we do that for the second expression as well, right? This is the first coordinate. It means the distance, right? So it's 2, the radius is 2. And then we're going to use the formula x is equal to radius 2 times cos of this angle, right? This is negative 5 pi over 3. And we're going to plus 2 pi to it to kind of simplify this angle. Plus 2 pi, you have just pi over 3, right? And this cos pi over 3 is equal to 1 over 2, right? 1 over 2 times 2 is equal to 1. Okay, that is straightforward. And then also this sine of pi over 3, right? That is square root of 3 over 2. So this becomes square root of 3. And now this point can be converted to 1 square root of 3. Okay, that's the Cartesian coordinates. And for the question C, that is a little bit different because we have negative radius here. When we have such a form, we need to convert that into the positive radius form first before we do the conversion, right? So when we flip the radius, we also flip the angle to the other side, right? So the other side, that means we need the plus pi. Right? It's the other side of the unit circle. So this becomes positive, right? And the angle here becomes this angle plus pi. Well, what is this? This is 4 pi minus 3 pi over 4, right? And we can kind of ignore this 4 pi because it has the same, it's located in the same position as the 3 pi over 4 is. So now after we figured out radius is 2, we can use x equal to radius times cos of this angle, negative 3 pi over 4, that is 1, right? And y is equal to this sine 3 pi over 4, that's negative 1. So we finally managed to convert this into our Cartesian coordinate, which is 1, negative 1, like this. That is question 6. Very simple, I think, as long as you remember the formula. And also remember to flip the sign here. When you flip the radius, you also convert the angle to the other side. So that is question 6. And moving on to question 7, find two pairs of the polar coordinates, right, where theta is from negative pi to pi of the following points that were given in Cartesian coordinates. So firstly, for this 0, 4, right, we're going to compute the radius first, right? Radius, the formula is radius squared is equal to x squared plus y squared. So 0 squared plus 4 squared is going to give you 16. Okay, so we will have radius equal to 4, right? So radius equal to 4, and then we use the formula cos theta equal to x divided by radius. So it's 0 over 4. We figured out the cos theta is 0. So we can select one possible theta here, that is theta equal to pi over 2. And we check that this theta equal to pi over 2 is in this range. So that is a valid angle. Okay, valid angle. So our first point here is radius 4 with angle pi over 2. That is our first pair. But we need two pairs here, right? So we need to find the other one. So that is easy. We just need to flip the radius so that the radius becomes negative. But in the same time, we also need to flip the angle. So the angle goes to the other side of the circle. It was originally pi over 2, which is here, right? And it goes to the opposite, it goes here when you plus pi or minus pi, okay? So when it goes here, if you plus pi, it could be 3 pi over 2. But notice that 3 pi over 2 has exceeded the upper bound of this one. So you should not plus pi, and you should minus pi, right? So pi over 2 minus pi gives you negative pi over 2. So we found our angle here, negative pi over 2, with a radius negative 4. That is the second pair. And now moving on to the next one, we compute the radius first, right? That is radius squared equal to x squared plus y squared, 12. And our radius now is 2 square root of 3. And then cos theta, that's going to be x over r, right? So it's square root of 3. This is x divided by r. That is equal to negative 1 over 2 here. And because cos theta is equal to negative 1 over 2, so our theta should be here, right, in this position. That corresponds to the angle 2 pi over 3. Now, after we have the angle, we write our first pair, that is radius 2 square root of 3 with angle 2 pi over 3. Okay, our first pair. And for our second pair, we use the same idea. We convert the radius into the negative radius, and then in the same time, we also flip the angle to the other side. So this goes to the other side, right? So that means you need to plus pi or minus pi, depending on situation. And you see that if you plus pi, that angle becomes way too large and it has exceeded the upper bound here. So we need to minus pi. So this thing minus pi gives you negative pi over 3. So that is our second angle here, our second pair. Negative 2 square root of 3, negative pi over 3. Now we move on to the last question, question C, right? Compute the area, the radius square, that is 7 square, 7 square, 89. And now you have radius equal to 7 square root of 2. And cos theta is x over radius, which is 7 over 7 square root of 2, which gives you 1 over square root of 2 when these two 7's cancel. And now we have cos theta equal to 1 over square root of 2, so theta is pi over 4. That's one possible theta. And we check that this theta is in this range, right? So it's a valid angle. So that gives us the first pair, radius 7 square root of 2 with angle pi over 4. And we also need to find the other pair. Idea is the same. Flip the radius so it becomes negative. Okay, but in the same time you also need to flip your angle. So it was pi over 4, it was here, pi over 4. And then it goes to the other end, goes to here, right? So this point is negative 3 pi over 4. Okay, so that is gonna be the angle. This is negative 3 pi over 4. Okay, so I think that is all of the questions here. I will see if you guys have any questions. Speaking of the tutorial, it will always be posted. Any questions?